Well, hey there, kiddos. Two things before we start this video. Number one, there is a copy of these notes on Edline under the notes folder so that you can go grab them. You might need them when we get to the graphing part of this lesson. Number two, I want to give a shout out to Angel for working so hard this semester. He's been doing a really good job getting his homework done and watching the videos, and I just want to say I'm really proud and keep it up. So now let's talk about systems of inequalities. We have done inequalities before. We did one where we graphed an inequality and that was it. So let's review a few things first just to make sure we all remember. Okay, in order to graph a line you need two things. You have to have the slope and you have to have the y-intercept, which means that in order to graph, your equation needs to be in this form, y equals mx plus b, because that's slope-intercept form, and m is the slope and b is the y-intercept. So when you graph inequality, some things to remember. It is going to be a dotted line if your graph or if your symbol is either greater than or if it is less than. If it is greater than, you will shade up or above the line. If it is less than, you will shade down or below the line. If you are going to graph an inequality and it needs to have a solid line, then it will either be greater than or equal to or less than or equal to. And again, greater than shade up, less than shade down. We will practice this. Hopefully it will stick, but it's important to write this down so you can refer to this. So we're going to graph these two inequalities really quick. Oh, I forgot something. A solution to a system of inequalities is where the two shaded regions, because remember when we do an inequality we shade, it's where the two shaded regions overlap. And so we're going to graph two inequalities this time, and they're each going to have their own little shaded region, and where the shaded regions overlap is where you have a solution. So we're going to graph these two, and then we're going to look at the solution area and determine if these are actually solutions to it or not. So let's do this first one. I have y is greater than or equal to negative x plus 1. Because it's greater than or equal to, I'm going to shade up, and it is a solid line. And so when I graph, all that's going to be important. But right now, this negative x plus 1, my slope is the number in front of the x, which happens in this case to be a negative 1, and I'll put that over 1. And then my y-intercept is the number that's added or subtracted, so the y-intercept for this line is 1. So when I graph this, I get to start at the y-intercept of 1. And my slope is negative 1 over 1, so from that point I go down 1 and over 1, and I'm going to make a couple. And I can also go backwards. Instead of down and right, I can go up and left. So I can go up 1, left 1, up 1, left 1, and it will make, there's my line. So I'm going to connect these points and make a line, and I'm going to make a solid line because it was greater than or equal to. And so I'm going to connect my points. I know that's not right on it. I will fix it. So there is my line. And now I have to shade. Since it is greater than, I'm going to shade above the line. And if you can't remember how to do this, start at your y-intercept. And I want to go greater, so I want to shade everything in this direction. So I'm going to shade up here for that line. So I have now shaded. Now let's graph this other line. I have y is less than or equal to x. This is the linear parent function. Okay, except it's a linear parent inequality this time, because we have an inequality symbol. Since it's less than, this time I'm going to shade down, and this is still going to be a solid line because it's or equal to. So the the slope for this line is the number in front of the x, which in this case is 1 over 1, and the y-intercept is the other number, that thing that's being added or subtracted, but there is nothing added or subtracted, which means my y-intercept is 0. So I'm going to start at 0. And from there, I'm going to go up 1 over 1 this time. So I'm going to go up 1 over 1. And then I can go backwards. I can go down 1, left 1, so I can get all my points. And then I'm going to make a solid line to connect my points together. And so there is that line. And this time I need to shade. And again, I have to shade. But now I'm going to shade down because it is less than. So if I started at my y-intercept, I want to shade everything in this direction. So now I'm going to shade everything underneath my line. The part of the graph where the two shaded regions overlap, is where my solutions are. So my solutions are everything in this triangle right here, including the boundary lines. The boundary lines count for this graph because they are solid. If they happen to be dotted lines, the boundary lines wouldn't count. But because they are solid, then the boundary lines count. So let's determine if these lines are actually going to be solutions. And so, or if these points are going to be solutions. So let's start with the point 0, 0. Well, 0, 0 is right here. It's on a boundary line, but it doesn't happen to be inside the shaded region. So no, that's not going to be an answer. 2, 2. So we'll go over to 2, up 2. It's on a boundary line that is part of that triangle. Since it's the boundary line is solid, it's okay that it's on the boundary line. So yes, this will be a solution because it is on a boundary line that is part of that triangle we created. Now, -1, 4. That's in a shaded area, but it's not the overlapping shaded area. So no, that won't be a solution either. So let's do 4, 1. It is in the overlapping shaded area, so that one also counts. Now we have -3.5 and -1.5. There's not even any shaded stuff going on there, so that's not going to be a solution. So hopefully you can see what makes a solution and what doesn't. It's got to be in the little shaded region that we created. Let me change my pen color back here. Alrighty, so let's do a couple more. We're going to graph these two. I think on the one that I post on Edline, there are 3 inequalities. We're going to do the first one and the last one. You can try the one in the middle if you want afterwards, but I'm just going to do 2. So we're going to solve by graphing, and then we're going to name a point that lies in the solution area. So I have 2 lines here. Y is less than 1 and x is less than 1. This is a y with no x, and this is an x with no y. When you have this and it's just a y equals, or in this case a y is less than, this is a HOI. So this is a vertical line. Oh, my bad. It is a horizontal line where y equals 1. Because it is less than, I'm going to shade down. And because it doesn't have the or equal to, this has to be a dotted line. So when I graph it, I have to draw a dotted line. But I'm going to have my y-intercept. It's going to cross the y-axis right here at 1 because that's what it says. And I'm going to have a horizontal line that passes through that point right there. So there is my line. And now we have to talk about the shading. Because it is less than, I want to shade down. So I want to shade everything below that line. So all of that in there, all of this is my shaded area. So now let's do the x. X is less than 1. Well, this is going to be a vux because it has just the x. So this is a vertical line. And because it is less than, and it's vertical, I'm not really going to shade down this time. I'm going to end up shading less than, which we'll talk about in a minute. But this is also a dotted line because it is just less than. So we're going to, x equals 1 right here. And we're going to have a vertical line that goes through that point just like that. And this time when we shade, there's not an up or a down. There's just a left or a right. Well, if I want to shade less than, that is left of my line. And so the overlapping shaded region is this square right here that we have created. In this case, the boundary lines do not count as part of the solution area because the boundary lines for my region are now dotted instead of solid. So any point where the shaded part overlaps will count, but points on the line here will not. So let's pick a point, any point, but you need a point in the shaded region. So let's say this one right here, that's in the shaded area. This point right here will be a solution to this set of inequalities. Any point in this shaded region will work. This is just the one I'm picking. And so that one right there is -1, 2, 3. And -1, 2. Sorry, -1, 2. So it's at -3, -2. That point is in my overlapping shaded region. So that is going to be one of my solutions. So let's do another one. Before I can graph these two, y has got to be by itself. I can't graph it until it looks like this. It has to be in slope-intercept form so I can find the slope and the y-intercept. So I'm going to solve both of these for y. To do the top one, I'm going to start by subtracting 2x from both sides. and that gives me negative 2y is less than 6 minus 2x. Well, then when I divide both sides by negative 2, I get that y, and because I divided by a negative, this sign has to turn around. So now I have y is less than negative 3 plus 1x. So my slope here is 1 over 1, and my y-intercept is negative 3. So let's go ahead and start with graphing that. So my y-intercept is negative 3, and my slope is 1 over 1, so I get to go up 1 over 1. Or backwards, I can go down 1, left 1. And because this is just less than now, means I need to draw a dotted line. So I'm going to draw a dotted line through those points. And then I need to shade. Now I'm going to go with the final product, the one that was in slope-intercept form. I know it started greater than, but then when I solved for y, I ended up with less than. That's how I have to shade. So I'm going to shade less than my line down here. And we're going to do the other one. So now I have y minus x is less than or equal to 1. Well, I've got to get y by itself, so I'm going to add x to both sides. So now I have y is less than or equal to 1 plus 1x. So I have a slope of 1 over 1 and a y-intercept of 1. So we're going to graph it. So a y-intercept of 1, my slope is up 1 over 1. And this one needs to be a solid line because it has the less than or equal to. So I'm going to draw a solid line that goes through those points. And hopefully you notice when you look at this that these two lines are now parallel. If this were just a system of equations, these two parallel lines would give me no solution because they're never going to intersect. But because this is an inequality, we are looking at where the shaded region intersects. So we're concerned with the shaded part only. So I have to shade below the line because this is less than. So I have to shade everything under this line, the new one I just drew. So I'm going to start at that line and I have to shade everything under it. And so the shaded regions overlap in this triangle down here. Now the boundary line for this triangle does not count because that boundary line is dotted. It's not solid, so I can't put points on the boundary line. However, I can put points anywhere in the shaded region and they will be a solution to this set of inequalities. So let's pick this point right here. It is in the overlapping shaded region, and that point is at 1, 2, 3, 4, 5, 6, 1. That point is in the overlapping shaded region, which makes it a solution to this system of inequalities, as does any point in that overlapping shaded region. Just not points on the boundary line because it's dotted. Now, if you wanted to, you could try the third problem on your notes if you printed them from Edline and just see if you can do it. Ask me about it tomorrow, or, we can move on. So, now you have two inequalities. We're going to write the system. So, we're going to write the inequalities that go with these pictures. So, on this one right here, I'm going to call this line number 1, and I'm going to call this line number 2. And so for number 1, first of all, here is your line. It is solid, which means I'm going to have an or equal to when I write it. If you look, and what you want to look at for the shaded part, because there's all kinds of stuff shaded, look at this line and look at the double shaded part, because that's where they overlap. The double shaded part is above my line, which means I am going to have greater than or equal to as my symbol, because it is solid and I have shaded above it. Now for the important part, we got to find the slope and the y-intercept. To find the slope, pick two pretty points. Here's one and here's one. If you draw your right triangle so you can do your rise over your run, you get your slope is 1 over 1. So my slope is 1x, and my y-intercept is where it crossed the y-axis, which is 1. So the equation for line number 1 is x plus 1, is y is greater than or equal to x plus 1. Now line number 2 is a horizontal line, which tells me that it is going to be just y. What I have to look for is my symbol. If you look at your dotted line, the double shaded part is right here. It is below. So that tells me this is going to be less than, and because it's dotted, it's just less than. Now, since this is a horizontal line, all I have to worry about is the y-intercept, which is right here at 3. So the equation for that is y is less than 3. The hard part of this is just going to be figuring out which symbol to put. Y'all have written equations of lines before, and so that part shouldn't be new. Y'all saw questions like this when you were in the 8th grade, although they didn't include lines. What they included was just a point, but we're still going to do the same thing. So here's what we have. I have x is less than or equal to negative 13 over 2. The first thing I'm going to do is get a number, a decimal for 13 over 2. If I do 13 divided by 2, that is the same thing as 6.5. So this is telling me that x is less than or equal to negative 6.5. I just divided 13 by 2. Because this is just an x, that means this is going to be a vux. So it's a vertical line at negative 6.5. So I'm going to go to where x is negative 6.5 right here. And I need a vertical line through that point. And I need a solid vertical line because that has the little or equal to symbol. So I'm going to draw vertical line through that point. And then I need to shade. Okay, I need to shade less than that line. Well, that's everything over here. So if you will look, I have 2 points in that shaded region right now, B and C, which means A can't match and neither can D because they don't fall where I need them to. So it's going to be one of these 2 points, but I'm going to have to graph this line to figure out which one. So let's graph this line. I have y is greater than or equal to 1/2 x plus 5. Well, that y-intercept is 5 right here, and my slope is 1/2, which means up 1 over 2. And because this is also got an or equal to, I get to draw a solid line for that one. So I'm going to draw a solid line through those points. And then I need to shade. And I need to shade greater than that line. So I need to shade everything above that line. And the point that falls in the double shaded part is this one right here, B. C is still in a shaded part, but it's not in the double shaded part. Therefore, it's not the solution. So this is the point that satisfies both of those.